I'm Tom Benson, and I work at NASA, NASA. And when I say the word NASA, I'm sure the first thing that comes to your mind is the Space Shuttle, the Hubble Space Telescope, walking on the moon, maybe the International Space Station. And all of those are NASA. But that's NASA space flight. There's more to NASA than just space flight. Sprinkled around the country are 4 NASA research centers. And we are lucky here in Cleveland to have one of those centers. It's out by the Hopkins Airport, that's where I work, at the NASA Glenn Research Center. There are about 4,000 people that work there, about 700 engineers. I'm one of them. And we're trying to figure out new ways to make more efficient propulsion, better power, use of power, and communications. So when I was asked to come and give this talk about creativity, I did what any engineer would do, and I grabbed a piece of scrap paper and a pencil and started writing down what I thought the chief characteristics of a creative person is. And I ended up with a list with about 40 things on it. And unfortunately, it's kind of a bad list, and it's too long to discuss here. So what I did was, sort of in the spirit of David Letterman, I took the top 10, and this is my top 10 list of the nature of creative people, or the characteristics of a creative person. This is my list. And hopefully today, with the interaction here in the crowd, we'll be able to discuss some of these items. This is my jumping off spot. All of the people I know who are very creative are really smart. And they are experts in usually some rather narrow pursuit of science or engineering. And they're experts. They know what's wrong with things that they do. That's how you're able to break the mold. If you're going to come up with a new idea, you've got to know what's wrong with the old idea. So you've got to be kind of an expert at that. You've got to have guts. You've got to have courage to propose a new idea. We like to think that when you propose a new idea, you hear a lot of people talking about, oh, we need to innovate our way out of this problem, or we're going to be very creative. And what happens a lot of times when you come up with a new idea is you're not met with, oh, that was great. You're met with people that belong to the old form, and you'll be met with resistance. It's just the way it works. It's the nature of things. It's probably the people with no guts want to fight the people with guts. And so you're going to encounter resistance. And to overcome that, you have to be persistent. You have to go at it day by day. Being creative is a leap of faith. Again, back to the guts issue. You're going to risk your career. You're going to try something that's never been tried. And that's cool. And when you try something that's never been tried, you're going to need a little bit of luck. Because you're going to have to make some choices on which you have no data. You're going to have nothing to back up what you're going to try to do. And if you make the right choices, if you're lucky, you'll become creative and famous. And if you make the wrong choices, you'll fall back and you'll never be heard from again. Unless you're persistent and can work out the answers. You've got to be at the right place at the right time. That's this environment and timing. If we think about Leonardo da Vinci had a beautiful drawing of a helicopter. He had the right idea. He didn't have the right motor. He was at the wrong place at the wrong time. So to be successful, you've got to have a bit of luck. You've got to be at the right place at the right time. You've got to have a lot of interest. You're going to be an expert in one area, but usually you have interest in lots of other areas. I put a big S, underlined S on this. Usually an inspiration comes from one of the other areas. We find, I think, a lot of times that a creative idea is really the synthesis of a whole bunch of different ideas from different areas put together. The creative person can put the things together in a way that's different than everybody else. The aha moment. When you put things together, you've got to recognize, oh, that's how that works. Yeah. Sometimes there's an unintended result in the aha moment. I'm working on this problem, I suddenly get the solution to this problem. And you've got to be able to recognize those. Kind of interesting. And the last one on the right there, the muse. When you're trying to be persistent, most people lose heart. When you meet enough resistance, it's tough to keep going. And you need somebody that you can bounce ideas off of, somebody that believes in you and somebody that can push you on. All of us have that. It's kind of cool. So that's my top 10 list. Those are examples. And rather than just discuss the examples, let's take a look at an example. And this is going to be an example from my own career out at NASA. And it has to do with shockwaves. This is a shockwave. This is actually a picture of flow going by a model, and these lines that you see coming off of there are shockwaves. Now, what's a shockwave? Shockwave is Mama Nature's solution to an interesting physical problem. When we go and move some object through the air, sitting in the air are a bunch of molecules and they're all colliding with one another. And as I move this object through there, I displace all the little molecules that happen to be sitting where the object comes by. I give them a little velocity. I move them out of the way. And as I move them out of the way, they create a little wave. These molecules collide with the next group of molecules, collides with the next group of molecules, collides with the next group of molecules. And there's a wave that gets sent out. And that wave travels at a certain speed. It's called the speed of sound. Why is it called the speed of sound? Because that's what sound is. My voice is talking here, it's creating a little disturbance. The disturbance is moving through the air. When it hits your ear, your brain turns it into a sound. And that transmission of information is done at a characteristic speed that depends on the nature of the gas and the temperature of the gas. Fantastic. The trick is that when I move my object through here, I can move it at any old speed I want. The disturbances are being transmitted at the speed of sound, but I can move this object faster than the speed of sound. And when I do that, I cause a big problem. And the solution to the problem, is that Mother Nature creates these shock waves. And across the shock wave, the properties of the air itself change. The pressure jumps up, the temperature jumps up, the density jumps up. Now the pressure jumping up causes a problem. The forces on this airplane when it flies are indicated by its pressure. And if the pressure goes up, there's more forces on that object. You actually start encountering drag as you start to approach the speed of sound. It's called wave drag. That's the origin of what we thought was going to be the sound barrier back in the 1950s. They saw this drag going up the faster we got to the speed of sound. The temperature going up is a really big problem. When the Space Shuttle comes back from outer space, there's a big shock wave on the front because it's going 25 times the speed of sound. The temperature jump across that shock wave drives the temperature behind the shock wave to 5,000 degrees Fahrenheit. That's as hot as the surface of the sun. And it's not caused by friction with the air, it's caused by that shock wave. So the shock wave generates temperature, generates pressure, changes the density. If you go out to the Cleveland Air Show, and you see an airplane go by real fast, sometimes you'll see this cool phenomena, which is a big old shock. That's an indication of the shock wave right there. It's condensation shock. It's kind of cool. Anybody ever see one of those at the air show? It's startling. It's kind of cool. What you don't realize is when you fly on an airliner at 35,000 feet at 500 miles an hour, there's a shock wave sitting out there on the wing as well. Can't see it. It's invisible. Sometimes if the sun's just right, you can see a little line on the wing. But that's a shockwave, and it's causing some drag, and it makes a little bit of a temperature dent. So engineers want to know what that is. If we're going to be designing, we've got to know what that is. And when we went to school, we studied all the math that goes with, with how that works. And this is why people drop out of aeronautical engineering. Probably from the back you can't see it either, but the numbers on this guy is equation 115, 116, 117. This is a page from one report on compressible aerodynamics, and there are like 200 equations that describe all this stuff. And us engineers used to learn how to do those. When you actually became a working engineer, you didn't go into all those crazy equations. We used performance plots. This is a little more information. That's the information you saw in those equations. And when I was in the Air Force working on F-16, I used curves just like this to figure out how the pressure was going to jump across the shocks on the F-16. That's really nice. When I came to work at NASA back in the 70s, late 70s, and I was in the early 80s, this is what 30 years of working in high-speed flow will do to you, okay? That's me. We use giant computers to solve the equations of motion. And these computers you paid for with your tax dollars cost about $22 million. I'm sitting at a $50,000 workstation. I would submit jobs to the computer. The computer would crunch for hours and hours and hours, and I'd get the answers back, and I'd have to figure out if they were right, and then that's what I used the workstation for. Yeah, we made about 25 copies of the codes. We gave them out to Boeing and McDonnell Douglas and GE and General Electric. It was all very good. I had a very successful career doing that. And then one day we got creative. And I got creative because my son was playing video games. And I would watch my son play video games, and I went in and tried to play the video games after he went to sleep. And a video game is something pretty cool. You've got a little box that costs $200. It's doing computers. It's a computer. It takes a little input from a joystick, and its output is going on my television. And I thought, well, that is really cool and cheap. So I went to my boss and said, could I try to make a little interactive program like this to do compressible aerodynamics? He says, sure. We're having a reorganization here at the lab. It's going to be 3 months of chaos. I'll cover you. So I went off and started to work on it. And in a short amount of time, I was able to come up with a little interactive piece of program that looks like this. That does shockwaves. Here's a movie from the computer that's showing you that as you change the input, this will solve those equations instantaneous. Now, originally I was running them on a workstation. This guy's actually running on a laptop. You can play with these things tonight in your home because it's available on the World Wide Web. Anybody, any place can play with this. Just Google up Beginner's Guide to Aeronautics, and you can find my. Well, when we started doing this, I had the aha moment. That's how I should have learned fluid mechanics, not memorizing 120 different crazy equations. So my career took a big bend, and I went off into education. And I built this one for shockwaves. I got one for airplane, for wings. I've got one for jet engines. I've got one for model rockets, all kinds of stuff. Now, this all sounds good. When I first started heading off to do education, I met a lot of resistance. We don't pay you to do education. No, you're supposed to be one of these engineers that helps McDonnell Douglas. That program there we talked about, I gave out 25 copies to McDonnell Douglas. That piece of software gets downloaded to somebody's computer 40,000 times a year. So I'm reaching a lot more people. And I'm having a lot more fun with it, obviously. So I want to leave you with kind of with this final thought. And that is to keep your eyes open. There's a lot of technology here in Cleveland, a lot of different kinds of technology. And you can access that technology and make a difference. Be prepared to fight for it. You have to do that as well. Also, keep a real open mind for possibilities, okay? Again, it's not always going to be popular. If somebody comes to you and you're a manager and wants to try a new idea, let them have it. All right, thank you very much.